Hello, boys and girls. Welcome back. I hope you guys are well rested, that you enjoy your weekend, and that you're ready to continue on with your chemistry lessons then. For this lesson, I need you guys to go back into your concentration lesson and review a little bit because this lesson requires a lot of that content. So, this week, we're actually going to be talking about acids and bases. What are acids and bases? Okay, I'm pretty sure that every now and then in your lives, you have probably said that you tasted something that tasted acid. Ooh, está ácido. Okay, you have probably tasted that, and you're right. Okay, you were completely right. Those things that you were tasting were acids, but we need to actually define what's an acid for that. Okay, so for this lesson, we're basically going to be talking about that. What are acids and what are bases? So, okay, let's move on. So, what is an acid? Yes, again, whenever you taste something and you have said it tastes acid, you are right. Acids taste sour and can be strong or weak electrolytes in aqueous solutions. These are the physical properties of acids. Okay? What is an electrolyte? Is any substance that can conduct electricity. Okay? Some examples of acids in your household acids are oranges, lemons, sodas, wine, and anything basically that tastes sour. What are bases then? In the most simplest of terms, a base is the opposite of an acid. So, a base tastes bitter, feels slippery, and are strong or weak electrolytes in aqueous solutions. Okay, just in case I forgot to mention it, aqueous solutions are any type of solution that has water, like a solvent. Okay? What are some household bases? Well, some of the medicines that you guys take for heartburn, for gastritis, okay, are bases. How do they work? Well, since they are the opposite of an acid, they neutralize the acid inside of your stomach. Baking soda, for example, some pipe cleaners or bleach, for example, and ammonia. All of those are bases. However, we can't simply just say that, oh yeah, an acid is anything that is sour, or a base is anything that is slippery. Okay? We can't say it that way. It's not that simple. So, because of that, even in the 1800s, three main theories appeared that would explain what is an acid and what is a base. The first one of those theories was Arrhenius' acids and bases. Svante Arrhenius proposed that acids are hydrogen-containing compounds that yield or produce hydrogen ions in aqueous solutions. He also proposed that bases yield hydroxide ions, okay, instead of the hydrogen ions. So, and we have an example over here. We have hydrochloric acid. In a decomposition reaction, it quite simply produces hydrogen ions and chlorine, which is according to what Arrhenius predicted. And an example of a base, which is sodium hydroxide, this, when it decomposes, it produces sodium and hydroxide, just like how Arrhenius predicted it will happen. But there came a problem with this theory. The problem came when chemists started working with ammonia. Ammonia doesn't follow this theory because it will not, first of all, ammonia is a base and it does not contain hydroxide ions. Okay? As a matter of fact, ammonia will take a hydrogen ion from water if it's mixed together. So, in a decomposition reaction, so to speak, ammonia is going to remove one hydrogen from water, which will eventually become hydroxide, and the ammonia will become ammonium with the extra hydrogen ion that it took from the water. So, because of this contradiction, Arrhenius' theory had to be revised. And so came the Bronsted-Lowry acids and bases theory. These two chemists proposed that an acid is a hydrogen ion donor and that a base accepts or will accept the hydrogen ion from the acid. Sorry, mistaken here. My mistake. From the acid. Okay? No hydroxide ion is needed for the base, and this theory solved the problem that Arrhenius faced with his theory. So if we go over again this with this reaction over here, this theory explains how ammonia behaves, because a base is basically going to accept a hydrogen ion from an acid. Even though water is neutral, in this particular reaction, it behaves like an acid. Why? Because it will give a hydrogen ion, becoming itself hydroxide, to ammonia, which is the base. And the base, in this case, accepts the hydrogen ion. So here we go. Okay? Here we go. So again, in Bronsted-Lowry acids and bases, the base is going to accept a hydrogen ion from the acid. Okay? Because water donated one hydrogen, it basically became hydroxide. Okay? Here's another example. Okay? The base in this case is the water. Okay? And here we have hydrochloric acid. So, which one donates the hydrogen? The acid. Okay? Which one accepts the hydrogen ion? The water. And becomes hydronium. That's the name of this ion over here. Okay? So, because this is no longer hydrochloric acid, the chlorine is basically left in an ionic negative state. Okay? Eventually, a third theory came along, which was very similar to the Bronsted-Lowry theory, but a little bit more explicit. Okay? It was the Lewis acids and bases theory. You might remember him, Gilbert Lewis, from the Lewis structure lesson. Okay? So, Gilbert Lewis proposed that an acid accepts electrons during a reaction, while bases donate those electrons. And that is true, in this case, for water, for example. If you remember the Lewis structures, when we're doing covalent bonding, what's going to happen in here? How is this compound over here going to be produced? Well, first of all, the oxygen has 6 electrons, while hydrogen has only 1. Okay? Remember that hydrogen fulfills the octet rule with 2 electrons. So it says in here, an acid accepts electrons. So in this case, hydrogen is the acid. And this hydrogen is going to accept 1 electron from the oxygen. And this other hydrogen is going to accept another electron from the oxygen, which means that the oxygen itself is going to be left with 4 of its original electrons, and it is going to share 2 of them with these 2 hydrogens. And those are the basic theories behind acids and bases. An easy way to summarize this is in this chart. You have the 3 theories. In Arrhenius' theory, an acid is a hydrogen producer, while a base, which is also called an alkaline, is a hydroxide producer. In Bronsted and Lowry, an acid donates a hydrogen ion, while a base accepts the ion. For Lewis, an acid is an electron acceptor, while a base is an electron donor.